Hey there, science fans! Welcome to Science in 10 Minutes, where we explore the wonders of the universe, one bite-sized chunk at a time. Get ready for a quick and fun dive into fascinating topics that make our world tick. No lab coats required. Today we're tackling a dynamic duo that powers our modern lives, electricity and magnetism. These two forces may seem different at first glance, but trust me, they're closer than you think. Get ready to unlock the secrets behind these incredible forces. We'll uncover their individual powers and then reveal the amazing connection that makes them an unstoppable team. Let's get started. Electricity and magnetism are everywhere. These two fundamental forces are not just confined to science labs or textbooks, they are an integral part of our daily lives. From the moment we wake up to the time we go to bed, we are surrounded by the wonders of electricity and magnetism. They're the driving forces behind countless technologies we use every day. Think about it. Every time you charge your phone, use your computer, or even switch on your coffee maker, you're harnessing the power of electricity. And let's not forget about magnetism, which plays a crucial role in the functioning of many devices, from simple fridge magnets to complex MRI machines in hospitals. From the smartphones in our pockets to the lights in our homes, these invisible forces shape our modern world. Imagine trying to navigate your day without these conveniences. No GPS to guide you, no internet to connect you, and no lights to brighten your night. It's almost unimaginable, isn't it? Imagine a world without the hum of refrigerators, the glow of televisions, or the speed of electric trains. These everyday items, which we often take for granted, rely on the principles of electricity and magnetism to function. Without them, our lives would be drastically different, and many of the advancements we've made as a society would not have been possible. It's hard to picture, right? A world plunged into darkness, devoid of the technological marvels that make our lives easier and more enjoyable. But this hypothetical scenario helps us appreciate just how vital electricity and magnetism are to our existence. That's because electricity and magnetism are essential to our modern way of life. They power our cities, keep our homes comfortable, and enable us to communicate with loved ones across the globe. The intricate dance between these two forces is what keeps our world running smoothly. But here's the catch. These two forces aren't just useful, they're deeply interconnected. The relationship between electricity and magnetism is so profound that it gave rise to a whole new field of study, electromagnetism. This branch of physics explores how electric currents create magnetic fields and how changing magnetic fields can generate electric currents. Understanding one means understanding the other. When you delve into the world of electromagnetism, you begin to see how these forces are two sides of the same coin. This interconnectedness is what allows us to develop technologies like electric motors, generators, and transformers, which are the backbone of our electrical infrastructure. It's like a fascinating puzzle where the pieces fit together perfectly. Each discovery in the realm of electricity and magnetism adds another piece to the puzzle, bringing us closer to a complete understanding of how our universe works. The more we learn, the more we realize how much there is still to discover. So, buckle up as we unravel the mysteries of electricity and magnetism. This journey will take us through the history of these forces, from the early experiments of pioneers like Faraday and Maxwell, to the cutting-edge research being conducted today. Along the way, we'll explore the practical applications of these forces and how they continue to shape our future. Get ready to see the world in a whole new light. As we dive deeper into the wonders of electricity and magnetism, you'll gain a newfound appreciation for the invisible forces that power our lives. So, let's embark on this electrifying adventure together and illuminate the secrets of the universe. Let's start with electricity, the invisible force that makes our devices come alive. Every time you turn on your smartphone, boot up your computer, or switch on a light, you're harnessing this incredible power. But have you ever stopped to wonder what electricity actually is and how it works? But what exactly is it? How does this unseen force power our modern world, from the smallest gadgets to the largest machines? In simple terms, electricity is the flow of tiny particles called electrons. These electrons move through materials, typically metals, which we call conductors. This movement of electrons is what we refer to as an electric current. Think of it like water flowing through a hose. Just as water flows from one end of the hose to the other, electrons flow through a wire. The water molecules are like electrons, and the hose is like a wire. The electrons move from one atom to another, creating a flow of electric charge. When we turn on a switch, we're essentially opening a valve, allowing those electrons to flow through the wire, creating an electrical current. This current is what powers our devices, lights our homes, and runs our appliances. Just like water pressure, electricity has something called voltage, which is like the force pushing those electrons through the wire. Voltage is measured in volts, and it determines how much energy each electron carries. And just like the amount of water flowing through the hose, electricity has something called current, which measures how many electrons are flowing. Current is measured in amperes, or amps for short, and it tells us the rate at which electrons are moving through the circuit. So the next time you flip on a light switch, remember those tiny electrons zooming through the wires, bringing light and life to our world. It's fascinating to think about how something so small can have such a big impact on our daily lives. The journey of electricity doesn't start in your home though. It begins at power plants, where energy is generated from various sources like coal, natural gas, nuclear power, and renewable resources such as wind, solar, and hydroelectric power. This energy is then transmitted over long distances through high-voltage power lines. As electricity travels through the power grid, it passes through transformers that step down the voltage to safer levels for use in our homes and businesses. This complex network ensures that we have a reliable supply of electricity whenever we need it. Modern technology has also given us smart meters and smart home devices that help us monitor and manage our electricity usage more efficiently. These innovations not only save us money but also help reduce our environmental impact by promoting energy conservation. Renewable energy sources are becoming increasingly important as we strive to create a more sustainable future. Solar panels, wind turbines, and hydroelectric dams are all part of the effort to harness clean, renewable energy and reduce our dependence on fossil fuels. Understanding the flow of tiny charges or electrons helps us appreciate the complexity and ingenuity behind the technology we often take for granted. From the moment electrons start their journey at a power plant to the instant they light up a bulb in your home, it's a remarkable process that powers our modern world. So the next time you use your smartphone, turn on a light, or power up your computer, take a moment to think about the incredible journey of those tiny electrons. They are the unsung heroes of our daily lives, making it possible for us to enjoy the conveniences and comforts of modern technology. Electricity is more than just a flow of tiny charges, it's the lifeblood of our modern world, connecting us, powering our lives, and driving innovation. Embrace the wonder of electricity and the amazing journey of those tiny electrons that make it all possible. Now let's talk about magnetism, another invisible force that's all around us. Magnetism is a fascinating phenomenon that has intrigued scientists and laypeople alike for centuries. It's a force that we can't see with our eyes, but we can observe its effects in the world around us. From the simple magnets on our refrigerator doors to the complex magnetic fields that protect our planet from solar winds, magnetism plays a crucial role in our daily lives. We've all played with magnets, those magical objects that attract certain metals like iron. As children, we might have marveled at how these small pieces of metal could pick up paper clips or stick to the refrigerator door. But there's so much more to magnets than just their ability to attract metal objects. They are a window into the invisible forces that govern our universe. But what makes them so special? Magnets are unique because they have a property called magnetism, which is the ability to attract or repel certain materials. This property arises from the motion of electric charges within the material. In most materials, these charges are randomly oriented, canceling each other out. But in magnets, the charges are aligned in such a way that they create a net magnetic field. Magnets have two poles, a north pole and a south pole. These poles are where the magnetic force is strongest. If you cut a magnet in half, you won't get a separate north pole and south pole. Instead, you'll get two smaller magnets, each with its own north and south poles. This is because the magnetic properties are inherent to the material itself, not just the ends of the magnet. And just like with electricity, there's an invisible field around every magnet called a magnetic field. This field is a region of space where magnetic forces can be detected. You can visualize this field by sprinkling iron filings around a magnet. The filings will align themselves along the magnetic field lines, creating a pattern that shows the direction and strength of the field. This field is what allows magnets to interact with each other and with certain metals, even without touching. The magnetic field extends beyond the surface of the magnet, allowing it to exert a force on other objects within its range. This is why you can feel a magnet pulling on a metal object even when they're not in direct contact. Here's the fun part. Opposite poles attract, while like poles repel. This means that if you bring the north pole of one magnet close to the south pole of another, they'll be drawn together. But if you try to bring two north poles or two south poles together, they'll push each other away. This behavior is due to the alignment of the magnetic fields, which either complement or oppose each other. So, if you bring the north pole of one magnet close to the south pole of another, they'll stick together. This attraction is a result of the magnetic field lines flowing from the north pole of one magnet to the south pole of the other, creating a continuous loop that pulls the magnets together. But try to bring two north poles together and they'll push each other away. This repulsion occurs because the magnetic field lines are trying to flow in the same direction, causing the fields to clash and push the magnets apart. Magnetism might seem like magic, but it's a fundamental force of nature, just like gravity. While gravity is the force that pulls objects toward each other based on their mass, magnetism is the force that arises from the motion of electric charges. Both forces are essential for the functioning of our universe, and they often work together in fascinating ways. And as we'll soon discover, it's deeply intertwined with our other invisible friend, electricity. The relationship between magnetism and electricity is a cornerstone of modern physics. When electric charges move, they create a magnetic field, and when a magnetic field changes, it can induce an electric current. This interplay is the basis for many technologies we rely on today, from electric motors to power generators.